Hey, ladies and gentlemen, here's your first half of the 3-4 linear programming notes. So linear programming, it's taking real life problems and doing the process called optimization. So you're finding the maximum or minimum values of something. So a lot of times companies use this to maximize profit, minimize costs, etc. And so it's called linear programming when we find those maximums and minimums. So linear programming model consists of constraints. And so those constraints is the system of linear inequalities you have. And then we have an objective function. So the objective function pulls in what we need to with maximum and minimum profits or something like that. So really our steps are to graph the system of constraints. So graph those inequalities. That's like what we did in 3.3. Then find vertices of the graph of the constraints. Those are finding those points of intersection. And that's like what we did in our last problem in our notes in 3.3. And then 3 is evaluating that objective. And so we plug each of the vertices in to that objective function, and that's going to get us our maximum or a minimum value. So we're going to work on problems 1 and 2 in today's video. So really we're just going to practice those graphing constraints, finding the vertices and plugging them into the objective function. We're not going to throw them into real world situations until the second half of 3-4. Okay, so first thing we're going to do is graph the system of inequalities. So let's go ahead and look at our first graph. X is greater than or equal to 1. So if it's an x equals or an x only inequality, it's a vertical line. And it's going to be at 1. And because it's got the equals to, it's going to be a solid line. And it says x is greater than or equal to. So we're going to shade to the right. And I'm just going to draw arrows, but you can go ahead and shade on yours if you'd like. All right, y is greater than or equal to 0. So when it's a y only in the inequality, we are going to have a horizontal line because it only is going to occur at the 0, and it's a solid line because of the equals to. And greater than 0, that's all of our values that are above the line. And then last we have here is this inequality here. It's in standard form, which we can do cover up to find our x and y intercepts, but the shading is easier when we convert it into slope intercept form. So this one is a simple one. I'm just going to subtract my 2x to both sides, and I get y is less than or equal to negative 2x plus 6. All right, so let's go ahead and graph that. My y-intercept is up at 6, and my slope is negative 2, but we want to think about that like negative 2 over 1. So down 2 and to the right 1, 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 and one more down 2 and to the right 1. Okay, it has an equals to, so it's a solid line. And it is less than, so we're going to be shading below. So I'm looking for that area that has all 3 arrows pointing to, and that's this triangle we have here. Okay, so this is my solution set. So I need to find the 3 vertices. So we have a point here, a point here. Ooh, that one should be that one should be more like here, and then up here. Okay, so my 3 ordered pairs are 1, 0, 3, 0, and 1, 4. All right, so I'm going to set up kind of like an XY chart, but it's going to have 3 columns. Okay, so my first column is going to be my X and my Y points of intersection. So I have 1, 0, 3, 0, and 1, 4. It doesn't matter what order you put those in. My middle column is going to be my work, and that's going to be with my function, my objective function, which is listed up here. So 3x plus y. So I'm going to have 3, and instead of x, I'm going to plug 1 in, and then my 0 in for y. And we end up with 3. So that's my last column as my value. And then I'm going to do the same thing here, but with 3, 0. So we end up with 9. And then the last step is to plug in my last point, which is 1, 4. And I get 3 times 1, which is 3, plus 4 gives me 7. So my minimum will occur at 1, 0. And my maximum occurs at 3, 0. So let's say we were talking about making something and we would say, oh, we'd make 1 of this and 0 of that to be my minimum value, or I'd make 3 of this and 0 of that to be my maximum value. So pause the video, rewind it, make sure you take the time to get this. We're going to throw this into real life situations in the second half, but here we're just practicing graphing and then finding the vertices and plugging them in. All right, so let's go ahead and try another one here with problem 2. So I'm going to go ahead and graph my inequalities. X is less than or equal to 2. Oh no, it moved on us. All right, so I'm going to put, it's just an X, so it's a vertical line, and it's equal to, so it's a solid line at 2. And it says less than 2, so all my numbers that are less than 2 are to the left of my line. All right, that middle line here, it's in standard form. We want to convert it. So I'm just going to go ahead and jot it over here. So I'm going to subtract my 3x over. So don't drop this negative here. I get negative y. I didn't multiply or divide by a negative yet. And then these are not like terms. So negative 3x minus 2. I need to get the y by itself, so I'm going to divide by negative 1 for everything. And because I'm dividing by a negative, flip that inequality. I almost forgot. 3x plus 2. So now this is the inequality I'm going to graph. So I'm up at 2, and my slope is now 3, and think about it as over 1. So up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. So that one's a little off, but we can do that. Okay, or down 3, 1, 2, 3, and to the left 1. Down 3, 1, 2, 3, and to the left 1. Down 3, 1, 2, 3, and to the left 1. It's important to draw those all out because you never know how far it is going to be before your line crosses. And so this is also a solid line. And if look at this, it's less than, so we're going to shade below. So I'm just going to draw my arrows in. You can go ahead and shade them. It's not going to be a problem. And then my last one here, I have y is greater than or equal to x minus 2. So my y-intercept is negative 2. And my slope is going to be 1 over 1. So I'm just going up 1 over 1, up 1 over 1. Okay, or I can think about it as down 1 to the left 1. And this is a solid line because it says greater than or equal to. And greater than means I'm going to shade above this line. So if you look, all 3 points, or all 3 lines, come to this red triangle. So I need my vertices where they cross. So I'm here at negative 2, negative 4. I'm over at 2, 0. And then I'm all the way up, so we're a little bit off, but 2, and then that's up at 8. All right, last step here is to do my table with my problems, my vertices, with my objective function, and then my value. So my vertices were 2, 8, 2, 0, and negative 2, negative 4. Ooh, I wrote negative 4, negative 4. My hand was not in sync with my mouth. All right, so you're going to go ahead and plug those values in. 2 times 2 minus 3 times 8. Okay, we get 2 times 2 minus 3 times 0. And then we have 2 times negative 2 minus 3 times negative 4. So go ahead and pause the video here and plug those answers, or plug those problems in, and see what you get for your values. All right, so we get 4 minus 24 here, so we get negative 20. We get 4 minus 0, so we get 4. And we have negative 4 plus 12. Ooh, -4 plus 12, and we get 8 here. So our minimum occurs at the ordered pair 2, 8, and our maximum occurs at our ordered pair -2, -4. All right, so tomorrow or the next day or whenever I see you again or give you instruction again, you're going to tackle 3 and 4, which are those lovely real life situation ones. All right, so go ahead and get started on your 3-4 worksheet and see what you can get done. See you guys.